So in this second half of the module, what we're going to do is think about how we can graphically represent this utility maximization problem that we saw in the first part of this consumer theory module. And so we're going to start off this graphical representation through something called the budget constraint. And so we saw a budget line or budget constraint way back early in the semester when we looked at the principles of economics and this idea of a trade-off between different goods. And so let's say here that Alex Robinson divides his total budget a little bit better, between two goods. So between two goods. So he just consumes two different goods, and let's say that there's mangoes and there's fish. And so he's spending his entire budget on these two goods, and so we're going to think of the budget constraint is the different combinations of mangoes and fish that Alex could purchase and we're going to assume that means he's going to consume them. So the budget constraint is the different combinations of mangoes and fish that Alex could purchase, spending his entire budget. So this is what the budget line or this budget constraint is going to be. And we're going to call these different combinations of fish and mangoes, or whatever two goods we're looking at, we're going to think of those as consumption bundles. So a consumption bundle is a particular combination of these two goods. So for example, like 200 mangoes and 200 fish, for instance, something like that. All right, so we're going to graphically represent the budget through this budget constraint. We're assuming there's just two goods that the consumer is choosing between, just like we were at the beginning of this module. Here they're mangoes and fish, as opposed to like pizza and soda or whatever we were looking at before. And so this budget line or this budget constraint is going to be all the different combinations of mangoes and fish that this consumer could afford when they're spending their entire budget. And we're going to call a particular combination of these fish and mangoes a consumption bundle. So for example, if Alex, given his budget and the prices of these two goods, chose to purchase 200 mangoes and 200 fish, that's a consumption bundle. All right, so let's do a quick example with actual numbers. We have an actual budget, and we can draw out what this budget constraint of this budget line would look like in this example. All right, so let's think of an example of a budget constraint with kind of real numbers that we can kind of construct a nice little graphical representation of this budget line. And then we'll kind of talk about more generally what that might look like. So let's say, for example, the budget that Alex has, or their income, is going to be $1,200. Say that's their budget per month or something to spend on mangoes and fish, I guess. And let's say that the price of fish, so I'm going to say P fish, is $4, let's say. So the price of fish is $4. And let's say the price of mangoes is $1. Well, with this information, we can draw out all the different combinations of mangoes and fish that Alex could afford if he spent his entire budget. So if we, and again, this is not going to be to scale since that's definitely not my specialty. And then, so here's our Cartesian plane. And on the two axes are going to be the quantities of these different goods that we're purchasing. So for example, let's say we have M for mangoes on the y-axis. Well, the units here is the number of mangoes that Alex is purchasing or can afford, or that kind of thing. And so on this x-axis is the number of fish that Alex can afford at this point. Okay, and so then we can try out all the different combinations. So on this, the first thing we can figure out is this intercept, this y-intercept here. And to figure that out, what we're going to take is our budget, so that's $1,200, and think about if Alex just spent that money on mangoes, how many he could afford? Well, he could afford 1,200 mangoes, right? The total budget, 1,200 divided by 1, the price. And then we can look at the other intercept down here and say, well, he has a budget of $1,200. If he spent all of his money on fish, he could get 300 fish. So how we got that is 1,200 divided by 4. So the total budget divided by the price would be how many you could buy of that good. And because the prices are remaining constant here, we can draw this nice straight line between these two intercepts. And this is going to be what our budget line is. So it's a nice straight line because Alex's decisions on what to purchase aren't going to affect the price. So him deciding to purchase more mangoes isn't affecting the price of mangoes, and him deciding to purchase more or less fish isn't going to affect the price of fish. So everywhere along this line represents, or we can represent the equation for this line as $1,200 equals the price of mangoes times the quantities of mangoes, plus the price of fish times the quantity of fish. And so here we know the price of mangoes is $1, the price of fish is $4. So it's showing us all these different combinations. If Alex was spending his entire budget on mangoes and fish, all the different combinations he could afford with his budget. So we can also figure out the slope. So the slope of this line is going to be the rise over the run. Well, the rise is negative between these 2 points. Negative 1,200 because the line goes down by 1,200 units and over by 300. So the slope is negative 4 because that's the rise over the run. And that's negative 1,200 over 300. So that's how I got that slope. So this is the rate of substitution in the sense that in order to get one more fish, Alex, I should say, will have to give up 4 mangoes to be able to afford one more fish. So it's showing us the trade-off in terms of our budget, the substitution in terms of our budget. Not to be confused with the marginal rate of substitution, which we'll talk about in a bit. So this is how budget constraints work. We have 2 goods on either axis, the quantities of the good on the axis. To figure out what the y-intercept is, we take whatever good is on the y-axis, I should say, and take our budget divided by the price of that good on the y-axis. Do the same thing for the good on the x-axis to figure out this intercept, and then draw a line between them. And that's going to be our budget constraint.